Hello everyone, my name is Sang Lee. Let me introduce the paper named Retrofitting Word Vectors to Semantic Lexicons. Before introducing the methodology, let me show you the important terminologies here. The first one is vocabulary. A vocabulary is a set of word types, W1, W2, and so on. The next one is ontology. A ontology, omega, is a undirected graph. It has one vector for each word type in vocabulary. And an edge, wi, wj, has a semantic relationship between wi and wj. The last one is the q hat. It is a matrix that is a collection of vector representations. In this case, the vector representations are d-dimensional vector for each word type in vocabulary. This is the objective of the paper: to learn the matrix Q such that each Qi is both close to its counterpart in Q hat and adjacent matrix in omega. It means retrofitting Q hat into Q. Figure 1 shows how retrofitting happens. The white vertices are the ones from Q hat and the gray ones from Q. The objective is that inferring gray ones from white ones while considering adjacent vertices in ontology. The equation on the right shows the objective function. It has two parts. The first one consists of Euclidean distance between Qi and Q hat I. And the second one consists of Euclidean distance between Qi and its neighbor in ontology, Qj. As you can see, the objective is minimizing the objective functions. This is the training procedure of this approach. The first step is training word vectors. After that, the Q hat will be trained with some word embedding approach. And we initialize the Q so that the vectors in Q are initialized to be equal to the ones in Q hat. The second step is retrofitting. Here we will retrofit Q with semantic lexicons ontologies. To minimize the objective function in previous slide, we take the first derivative of the functions with respect to one Qi vector, and by equating it to 0, arrive at online update. Let me introduce you the semantic lexicon during learning approach. Prior approach. This approach is to improving word vectors using lexical resources like ontology. They alter the learning objective with a prior or a regularizer. Doing this encourages semantically related vectors to be close together. PQ is the prior of Q and is proportional to formula on the right. The formula on the right considers adjacent vertices in ontology. Prior approach will be used as baseline in the experiment. It is based on maximum of posteriori and lazy or periodic method. This is word vector representations that will be used in experiments. globe vectors and skigram vectors, global context vectors, and multilingual vectors. This is semantic lexicons that will be used in experiment, PPDB, and WordNet and FrameNet. And table 1 shows it shows their approximate size of graph. This is the evaluation benchmarks that will be used in experiments, word similarity and syntactic relations, and synonym selection TOEFL, and sentiment analysis essay. And this is the kind of experiments that have been conducted. This is research for retrofitting. This is research from semantic lexicon during learning. We use LBL word vector representation as baseline. The table 3 shows 3 kinds of methods: baseline and prior approaches and retrofitting. And this is research from comparison to prior work. And it shows that retrofitting outperformed the prior works. And this is the multilingual evaluation research. This is end of my presentation. Thank you for listening.